vector and scalar projection of vector B onto vector A. Take a look at this graph. This graph shows that vector PQ and vector PR of two vectors A and B with the same initial point P. So if S, which is right here, is the foot of the perpendicular from R to the line containing PQ, then the vector with representation PS, this red vector right here, is called the vector projection of B onto A. So that is written right here. PS is called the vector projection of B onto A. So vector projection of B onto A, and this is denoted by PROJ. So the PROJ represent projection, and then vector B onto vector A. You know what? Actually, I should add a vector symbol right over here, and then the formula is you have the dot product of vector A and B divided by the magnitude of A, and then multiply vector A, I forgot the arrow again, and then divided by the magnitude of vector A. There are two ways to write it. You can either put the magnitude like this, so magnitude of A multiplied by itself, or you multiply the two magnitudes together. And then also the scalar projection of B onto A. So the scalar projection of B onto A, that is also called the component of B along A, is defined to be the sign magnitude of the vector projection. So here is the scalar projection of B onto A. So B onto A. You know what? I keep forgetting adding the arrow to the vector. So vector B onto vector A, the scalar projection is the dot product of vectors A and B divided by the magnitude of A. So I have two vectors, A and B, so I would like to find the vector projection and the scalar projection. The math is pretty simple, so let's match the color first. For the vector projection, I would like to find the dot product first. So we have A and then dot B, that is equals to 1 times 2 plus 4 times 3. That one is equals to 12 plus 2 is 14, and then the magnitude of A, that is equals to the square root of 1 square plus 4 square. 16 plus 1 is 17. So now we have all the ingredients to do the work. And then let's do the scalar projection. So we have scalar projection of B onto A, that is equals to the dot product, which is 14 divided by the magnitude, which is square root of 17, and then the vector projection, so PROJ, and then vector B onto A, that is equals to, you take either one of those. Which one do you like? We have a square root, we can pick the second one. So the dot product is 14, and then you square the magnitude. So this is in square root. Once you square that, you get the 17, and then vector A is 1 comma 4. Alright, so that means you have a fraction multiply a vector, so the projection is here. So you have 14 over 17 multiplied by 1, so 14 over 17, and then 14 times 14 is 56, and then divided by 17. Okay, so that is the projection of B onto A. So according to the picture, the projection of B onto A, so whatever this vector is the vector right over there. So we have a vector A, we have a vector B, and then this 14 over 17 comma 15 over 17 is right here, the projection. Okay, let's move on to the purple problem. The purple problem, same thing. We find the dot product first. So vector A times vector B, that is 1 times 5. There is no J in B, so that will be a 2 times 0. And then 3 times -1, so that is 5 minus 3 equals to 2. And then the dot product is found, and then we have the magnitude of A, which is equals to the square root of 1 square plus 2 square plus 3 square. So that will be 9 plus 4, 13. 13 plus 1 is 14. So square root of 14. Alright, so let's do the scalar projection, because that is easier to find. So that is compute vector B onto vector A. So that is equals to the dot product, which is 2, divided by the magnitude, which is square root of 14. The job is done for the scalar projection. And then for the vector projection, we have projection B onto A that is equals to let's pick this this piece. Either one is fine. We have the dot product. The dot product is equals to 2, and then square the magnitude is the square root of 14, and then square, and then we multiply vector A. So vector A, then that will be the ijk, right? So that will be the I plus 2j plus 3k. So this one we have a 2 over 14 in front. So that one we have a 2 over 14. By the way, 2 over 14 is equals to 1 over 7. So we have 1 over 7 times I, and then plus 4 over 7 times j, and then 1 times 3 is 3 over 7k. So that is the vector projection of B onto A. And then that is also the end of this video. If you like the way I explain scalar and vector projection, give this video a thumbs up. If this is something that you wanted to see, give a subscribe to my channel, and trust me, it is worthwhile coming back to visit for more math lesson. As always, signing out and take care.